This video is just going to talk you through some basics of object-oriented design. I borrowed the slide deck from this website. It is actually a course in Java, but I'm just going to use the first few slides to talk you through some concepts about OOP. So in old-style programming, which is actually what you've kind of been doing so far in C++, you have data, which is working passively. Those are your primitive data items that you guys have been working with, and you write functions that manipulate that data. And you just got done learning how to write some basic functions. We'll learn a lot more as we go along. But now we're going to work with objects that contain both data and methods. An object is active. It is not passive. It does things. So the methods that you write for an object are its actions. An object is also responsible for its own data, which means it has to keep track of who's accessing the data, and that's often why we keep the instance fields private, so that you cannot accidentally change the data within a class. You can expose that data to other objects using your getter methods and using your setter methods. And so it's pretty typical that you have getters and setters for every instance field that you create. An object also contains both the data and methods that manipulate the data. The data also represents the state of the object. So you might have a checking account that has a balance, and so the balance is the state of that account, meaning how much money you have, and based upon that you can maybe make a withdrawal, or you might not be able to make a withdrawal from your checking account if you don't have enough money. So if the status of your account goes into default because you don't have enough money, then that's considered the state of the object. The data can also represent relationships between objects and other objects. So an owner might be representing a person, and a person, if we want to use this checking account reference, could have several checking accounts. So the owner of the checking account, or an owner could have several checking accounts, and based upon those checking accounts, the owner may or may not have active status on several of those accounts. So it's kind of describing the relationship between the owner of the account and the actual account. So there's relationships that can be established. In an example here, if you're designing a game that has a rabbit in it, the object is going to be the rabbit, and the characteristics that you set up for the rabbit are going to be your instance fields or your data. You would set up maybe how hungry the rabbit is. That would be maybe also determine a status in the game. You could describe how frightened the rabbit is, or where it is actually at physically, like a location in the game. The methods that you might have could be that the rabbit could eat, hide, run, dig, and other things if you wanted. But what you want to look at here is these are actions, and generally the methods are action items, and your data, which would be your instance fields, are items that you can assign or keep track of a status. So hungry is a status, frightened is a status, where the rabbit would be at on the screen is a status, versus the actions, which are going to be your methods. When you work with classes, every object is an instance of belongs to an instance of a class. So when you create an object, it's of a class type. The object will have fields, which you've heard me just say instance fields. Those are the data, and the class will describe those fields. And then objects have methods, and the methods are the actions. Think of a class also like a template. You don't actually have an object until you create an instance of it. So the class is like a cookie cutter. So if I were to get some Play-Doh out and we were to make Play-Doh cookies using a cookie cutter, then each individual cookie that we make is an instance of that class, and the cookie cutter is just the template. And so when you're doing that, if I were actually stamping out different cookies or shapes with my Play-Doh, then I'm constructing those objects. A class is considered an abstract data type. And so this abstract data type bundles together your data and then the operations. The operations on the ADT are the only operations permitted on that data. Like nothing outside of that class can access that data. No other operations that are defined outside the class can work within that class. That's not exactly what I wanted to say. Basically, you can only use the methods that are within the class that you define. So here, this example is saying that if I have a checking account and I have operations, deposit, withdrawal, get balance, those are the only operations I can do on a checking account unless I decide to define something different. Class enforces that bundling. So it's the idea that you have data and you have these methods to work with the data. That's that idea of bundling. If all the data values are private, a class can enforce this rule, and it defines operations are the only ones permitted on the data, meaning you want your instance fields to be private so that you can protect that data. So then you access all of them using getters and setters. This particular example here is an example from Java. And so you have, which would be familiar to your Greenfoot, is how it would look in Greenfoot. You have your private instance fields, you have a constructor, you have a method, and you have a getter. Everything here is virtually the same as it is in C++, very similar, okay? If we were to create this same class in C++, you would notice hardly any differences. The system.out.println would change to a cout, and we would use different, to concatenate, you use less than instead of the plus symbol here. Terminology wise, I think there's just a few things here, but when we say we create an instance, we're creating an instance of an object. A field would be are your instance fields, or your data fields is another word. Method could be synonymous to function, meaning that there is a slight difference, but you could use those words almost synonymously. And then sending a message to an object is calling a function. And so always look for the parens when you're noticing or you're calling a function. You're going to have parens. And this comment here that says these are approximately true, they're talking about, I believe, sometimes the difference between C++ and Java. They're approximately true because a function actually has a slightly different definition than method, but for our purposes we're going to keep it as it is. Also notice that classes can have hierarchies. We aren't going to get into this a whole lot in this class, maybe a little bit, but a hierarchy is when you have subclasses and superclasses. And this following information that's on this slide is going to be Java oriented. So just very quickly on this, that in Java everything is a subclass of the superclass, a subclass of the object, and that you could have several ancestors. And the reason I just want to glance through this quickly is you're going to see sometimes some hierarchies like this, but you want to use this ISA terminology to determine if something fits. For example, a file dialog is a dialog. A dialog is a window. A window is a container. You can use that phrasing to help you determine whether or not something should be a subclass or not. And in C++, you can have more than one root, but we are not going to be working with it in that way, but not in Java. In C++, an object may have more than one parent. And again, we are not going to be doing that in our C++, but it is possible. And Java has a single strict hierarchy, but that is not necessarily so in C++. So just wanted to get to that slide to point out some differences. I don't know if there's really anything else on this slide deck that we are going to look at. The rest of this slide class gets into inheritance. We'll just mention a little bit of it and then I'm going to stop. this slide deck. So the class describes fields and methods. Object of that class can have those fields and methods, but an object can also inherit fields and methods from a superclass. The fields described in superclass can be inherited in the subclass, and so are the methods. A class is not a complete description of all of its objects. And that's going to be where we cut this off. You can look through more of it on your own if you like. There are some additional examples in the slide deck. But the syntax is written in Java, and so I don't want to use any more of that. But it's not a bad slide deck to look at for the rest of the inheritance information.